चलो so now we have part second. ठीक है, part second is of EMF and terminal voltage resistance, but instead of that what we are doing, अभी हम कर रहे हैं part C. ठीक है, ठीक है, so it's a part C. ठीक है, and that is electrical energy and power स्टार्टिंग में हमने सबसे पहले ये लिखा था ना, इलेक्ट्रिकल एनर्जी को किससे डिनोट करते हैं, पावर को किससे डिनोट करते हैं. सो इलेक्ट्रिकल एनर्जी इज डिनोटेड बाय E and unit is joules, then power by P, energy is watt and kilowatt. Yes.
Yes, sir.
So now first one part is what is electrical energy. ठीक है, yes, any one of you, what is electrical energy?
Energy obtained by flow of charge. Energy obtained by flow of charge.
Energy obtained by flow of charge. ठीक है, see there is a basic theory one part in it. ठीक है, like what is basically energy. So energy are of different types है ना, energy basically are of different types. We have different types of energy. This we have already studied in which chapter? Work, power and energy है ना. Yes, ठीक है, energy of different types of energies are there. ठीक है, like we have mechanical energy, okay, then we have heat energy, which is also called thermal energy. Yes, heat energy also called thermal
Yes,
energy.
sir.
ठीक है, then we have chemical energy, nuclear energy. Nuclear energy is the energy which we get from the nucleus of an atom. ठीक है, yes, it's of two types like nuclear fission and nuclear fusion. ठीक है,
Fusion.
and that and
Yes, sir.
etc. ठीक, now and we all know one more thing, when we talk about the energy follows the law of conservation of energies is also there. Yes,
Yes, sir.
है ना. So law of conservation of energy. Wait a second, Ashrita, what is law of conservation of energy?
Energy can neither be created nor be destroyed. It can only be changed from one form to another.
Yes, energy can neither be created nor be destroyed. It can only transform from transfer from one
One
form
form
to
to another.
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 So what example we can have in this? Any example? Give me any example.
Free
When
fall of
ball,
an object.
Hmm?
Free fall of a ball or any kind of object.
और थोड़ा सा वैसे दे दो नॉर्मल वाला. That is the conservation of energy of momentum.
speakers,
Speakers, हाँ speaker, what speakers do? वो भी ठीक था था पर
electric
लेकिन
sound
लेकिन
energy,
अभी नॉर्मल वाले बता रहे थे ना. स्पीकर में what happens?
electric into sound energy,
Electrical into electric
Sometimes
energy
heat, sometimes
to sound. Okay, then when we talk about the light bulb,
electric
Electric
into
light into
heat
huh,
and heat energy.
electric into light, and plus heat also, like in the, if it's a cadescent bulb, the heat also it provides,
yes sir.
है ना? So there are many things which has been transformed from one form to the another in the energy. Okay, there are many examples. This we already we studied in the work, energy, and power. Okay, so we are not wasting time on this one part. Now there are some examples also given in your book. Okay, like the examples is first one like examples given like what this energy is happening and how this energy is being coming from there. So let's talk about just in a brief only. Okay, so on passing electric current through the heating element, example wire of a alloy, electric heater, oven, geyser, it's get heated up due to its resistance. Electrical energy is converted into the heat energy which is used for heating purpose. So what it's saying, if you are having some coil like this, it's a coil, okay, and when you provide some current to it, okay, when you provide some current to it, so what I am providing, I am providing the AC current to the coil, okay. Okay, now this coil can be used in the heater, okay, on heater, geyser, oven, etc. Okay, now when the current pass through it, so because of the heating effect of electric current. Now this is the topic where we are studying the another effect of the current, and that is the heating effect of it. Okay, so already told you in the starting, current shows the three effects. Current shows three effect. Yes, one is the chemical effect of electric current. Second one is the magnetic effect of electric current, and the third one is the heating effect of electric current. So about this wire of the alloy, about this alloy wire, we have already studied in the previous class. Yes,
Yes sir.
है ना? So when the current flows through it, so due to its high resistance or the specific resistance, it doesn't allow the current to flow with the very fast rate. So due to which the friction will starts to increase. Okay, now because of this friction, the heat starts to generate. Because of that friction, heat starts to
Heat starts to
generate.
generate.
Okay, so now we are saying that in this condition, electrical energy is converted into heat energy. Yes, so this we have got. ठीक है?
Yes
So
sir.
what we are getting it again, we are getting the heating effect of electric current. Now another example which we can consider, ठीक है? Now another example is of electric lamp. ठीक है? Electric lamp. So what happened in the case of electric lamp? The lamp, which lamp we are talking about here? Filament lamp. Filament lamp. Okay. Is Nipun, Nitish, anyone joined?
Both are there.
Yes, sir.
In the filament lamp, which material we use? What is the material name? The filament which is made up of some element, na? What the name of this element?
Sir, in the
Hmm.
sir in the lamp, sir.
Hmm. Lamp means electric bulb.
Oh, the tungsten.
Tungsten, yes. Filament lamp, which is being used as a, in which tungsten, okay, tungsten is used. Okay, tungsten wire. Okay, so now what happened when this tungsten wire is got heated up? it's a glass chamber. Okay, so when the electric current pass through it, let's give AC only to this also. See, this is a symbol for an AC. Okay, alternating current. Okay, I'm
Okay.
just making a very simple diagram, not giving any resistance, nothing circuit, only just a AC current is being passing here. Okay, so this is a symbol for AC, that is alternating current. It's a AC supply. Okay. Now suppose it's a 100-watt bulb. So it's a 100-watt filament, and the filament is of, it's a filament. This is a glass, evacuated glass. Why the glass is there in the bulb? So that filament do not get oxidized. Okay, because when it just burn in the in air, it get just oxidized, and due to which it will break, and that's why we are covering it with the evacuated glass. Okay, got it?
So which gas is inside this? Which
Which type of what?
which gas is inside the glass?
नॉर्मल ग्लास, कांच होता है. हाँ,
मतलब
because
कोई
glass
inert gas नहीं होती है.
glass has very high melting point. Glass has very high melting point, है ना?
ठीक.
So it doesn't break. ठीक. Then also the glass which is been using, it's not normal glass, I am saying it, but that there's some qualities like it should
Direct.
melting point should be high. Its melting point should be high, and it should be not thick. देखा है ना, बहुत पतले पतले से होते हैं.
हाँ
Because
हाँ.
it will be thick, then it will also create some problem. ठीक है, so what is it? It will be thinner. Okay,
Yes sir.
so what is happening in this? So when the electric current is passing through it, the filament get heated up. Okay, so here the electric energy is converted into light plus heat energy again. Okay, so this also we have seen.
Yes
Clear?
sir. Yes sir.
Hmm. Clear है till here? Everything is clear up to everyone?
Yes sir.
Ashrita, Nipun, Nitish, clear?
Yes, sir.
Hmm.
Yes, sir.
I am taking all the examples because see, basic examples are there. Now the third one is about the electric motor. So in the electric motor, what is happening? Okay, so I am just writing it like this only. Already I have discussed in the work energy, but see, you have not studied the work and energy, na? Only one or two students see. That's why I am writing it. Okay, so in the electric motor. Now electric motor, what happens? Anyone? Navda?
Sir, mechanical
Electric
energy
energy,
electrical से use
mechanical
होती है.
energy.
मैकेनिकल एनर्जी. ठीक है, देखो एक्चुअली होता क्या है, व्हाट हैपन इन दिस, दिस इज द नॉर्थ, दिस इज द साउथ, एंड हेयर वी टेक सम coil.
सर उल्टा बोल दिया. इलेक्ट्रिकल मैकेनिकल यूज होती है.
हम्म
उल्टा बोल दिया मैंने. इलेक्ट्रिकल मैकेनिकल यूज होती है.
हाँ, तो इलेक्ट्रिकल मैकेनिकल में तो होती है. छोटा बोल दिया, ध्यान नहीं दिया मैंने.
मैंने उल्टा बोल दिया.
सी, आई एम जस्ट मेकिंग अ रफली डायग्राम हेयर, है ना. So basically what is happening, I have connected with some battery, and this is the coil in which when the current goes, so it is the carbon brushes, this is a split rings. Okay, these are the carbon brushes, these two are the split rings. Okay, and then when the current goes, so it goes in this direction, there's in this and this, then comes back from here. Now okay, because of the when the current pass through a coil, it is also start to have some mechanical energy due to which some force exerted. So here right now what we are not considering the magnetic one part, we are considering it. See, there's a fixed north and south pole. Okay, and that to a concave mirror we are using, sorry, not mirror, I am saying magnets. Okay, So the magnetic field is in this direction. This is the direction of magnetic field. Okay, and this is the electric current. So this we will study in the upcoming chapter. Okay, not right now. So what is happening in this? Whenever you are providing the electrical energy, it's converted into mechanical energy. Okay, because this motor starts to rotate. Na, motor starts to rotate, and rotate means that's mechanical energy. And along with the mechanical energy, one more thing comes, and that is the heat energy. How? Because see,
due
when
to friction.
because see, when you take a toy motor car of a motor of a toy car, okay, that is a 5 volts one motor comes ना, very small one, छोटी सी motors come, है ना,
Yes,
उसको
sir.
आप बैटरी से चलाओ. After a bit of time, what happens? It starts to be, when you touch it, its temperature is little bit more. Why? Because see, continuously if something is there, like mechanical energy is continuously moving it there, so because of the friction of that motor, heat is also being produced in it. Yes, clear है?
Yes, sir.
Yes, sir.
ठीक. Then next one is, next we have what? Next we have electric current through electrolyte. On passing electric current through electrolyte. सी ओनली दीज आर द थ्योरी. इसमें ज़्यादा थ्योरी कुछ है नहीं है चैप्टर में. ठीक है, इस वाले पार्ट में. थ्रू दी इलेक्ट्रोलाइट फॉर्मुलेज हैं. ठीक है, थ्रू दी इलेक्ट्रोलाइट. व्हाट इज इलेक्ट्रोलाइट? एनीवन, व्हाट इज
Solution from which electricity
इलेक्ट्रोलाइट?
can pass. A solution in which electrolysis is performed and in which electricity can be passed.
ठीक. कैसे बनता है? कि इलेक्ट्रोलाइट का एग्जांपल क्या हो सकता है?
Salt water.
ठीक है, दैट इज आल्सो कॉल्ड अ ब्राइन सॉल्यूशन,
हाँ.
है ना. ब्राइन सॉल्यूशन इज अ सॉल्ट वाटर.
हाँ.
ठीक है.
Acidulated water.
हाँ, और
Acidulated
Acidified.
water.
नॉट गॉट.
Acidified.
हाँ, एसिडिफाइड यानी कि डाइल्यूट H2SO4, that is sulfuric acid. Can dilute HCl work here?
Yes, sir.
ठीक है, and etc. many are there. ठीक है, so basically it's a solution. ठीक है, which has the ions in it. So when, okay, which has the ions means which has cation and anions in it. Okay, got it?
Yes, sir.
So in this, what is happening basically? In this we have the, suppose this is a container and we have two electrodes here. So this we have already studied in the chemistry very nicely, है ना?
Yes, sir.
है ना? Yes. Now let's give some current here instead of resistance. Let's give some current. So what will happen then? So these electrodes are there, and suppose this is the. So this solution is called the electrolyte, and these are the electrodes in which one of them is cathode, another is anode, and we have supplied some battery here. Then the reaction starts to take place. Okay, so in this, what is happening, like, see, if you supply energy then also it's okay, and if you just take out the current then also, like in the galvanic cell and Daniell cell it happens. Okay, so when we are studying the first second partner, then you will get to introduce with this one part. So already you have studied in your chemistry, that is a Daniell and galvanic cell के बारे में, like a electro cell. ठीक है, so but what is happening here? Electrical energy converted into, electrical energy is converted into केमिकल एनर्जी.
Chemical.
हाँ, केमिकल एनर्जी. ठीक है. Then let's talk about fifth. So electrical pulses from the microphone to the loudspeaker. So energy is converted into sound energy, and passing electric current in a coil wound around a soft iron bar gets the magnetized and becomes electron. So see what was this one saying. So let's not talk about this one, let's talk about this. So what it's saying, if you are having an electric bar here, sorry, iron bar, and that is made up of soft iron. Okay, so we will study in the upcoming chapter also this soft iron bar, soft iron. Okay, and we have just taken some round up coiled here on this, and when we pass some electric current in it, so what will happen, it starts to generate, it starts to generate okay, magnetic fields, magnetic field. So what is happening, it is just saying, it's also, it's been told by the Christian Hans Oersted. Okay, this is the Oersted also said कि a current carrying conductor introduces magnetic field in it, magnetic field in it. Okay, so that means what is happening here, electrical energy is converting into magnetic energy. What happened, feeling sleepy everyone?
No, sir. No, sir.
then शांत क्यों हो गए एकदम से?
10 seconds complete.
Okay, got it now?
Yes, sir.
Yes, sir.
ठीक है, now see, so these are the basic terminologies and everything about the energy. So see, if you get, it's given you the roughly idea of the things, ठीक है, how the things are working, what was the reason behind it, ठीक है, clear है इतना everyone?
Yes, sir.
Okay, now
Can I go to the previous slide once? Done. Thank you, sir.
now the thing is, now we have some very important formulas and everything, and how these formulas came through, ठीक है. So although the long derivations are not there, we don't have to consider anything bigger, only just this thing is, we need to remember these formulas, because without these formulas you won't be able to solve the questions, ठीक है. Now let's talk about measurement of energy, ठीक है. Now let's talk about measurement of energy. So what is energy? Basically capacity to do work, yes or no,
Sir.
Yes, sir.
है ना, yes or no? So what is energy? Energy is
Yes, sir.
capacity to do work.
Work.
Now suppose, yes, so if we have the potential difference, so we know we know what we know, work is needed to move a charge q through potential difference, ठीक है. Then only we get the potential difference na, yes or no?
Yes, sir. Yes, sir.
So for moving a charge from one point to the another point, we need to require some work. Okay, for moving a charge from one point to another point, we need to do some work. Okay, so basically we have potential difference is equals to work done per unit charge. So can we write that work done is equals to potential difference into charge?
Yes, sir.
Everyone, just try to remember
Yes,
and
sir.
start writing with me also. Okay, take your notebook and write it down along with me. It will be help you out. Or when done, please let me know.
Done, sir.
है ना, ठीक है, done everyone?
Yes,
Okay,
sir.
the formula we already know. Now what I am changing it now. We also know that I equals to, let's take the bigger one units only, ठीक है, not smaller. Yes, I equals to q by t, that is current. Current is charge charge per unit time. So this also we know. So put this now. Instead of this, I'll make charge is equals to IT. Put this in equation first. So equation first is, let this one is the equation number 1. Okay? So put it in it. So one formula, so we have got this one. First of all, let me cover with the block. So like this we can calculate the work, because amount and capacity to do work is the energy only. So one we have got here. Now another what we are doing, we are putting this Q is equals to charge equals to current into time, and put this in equation number first. So we will get, so what is the equation number first? Work done equals to VQ. So we will get work is equals to VIT. Got it? Everyone?
Yes, sir.
Yes, sir.
So one formula we got this one. Just try to remember how many formulas we are getting for solving the numericals. Okay? And by this only one math thing only, we are just replacing it with the other terminology and variables, and we are getting the same answer again and again. Okay? Clear?
Yes, sir.
Now,
Yes, sir.
so equation 2 done. Now we will introduce one more thing, and that is the from Ohm's law. So Ohm's law is equals to Nipun. What is Ohm's law? Formula for Ohm's law. Fast.
So for Ohm's law,
Hmm.
sir, not sure, sir. I'm sorry.
Ashrita.
Ohm's law. One
So
second.
V equals to something, sir.
Yeah, Ashrita, what is the answer? Arey Ohm's
So
law formula.
what is Ohm's law, or what is the formula of
Formula only. What is the formula of Ohm's law?
V is equals to IR?
बस निपुण फॉर्मूलेस याद नहीं हो रहे हैं
Yes, yes,
भाई,
sorry.
ये गड़बड़ मत करो इतना प्लीज, है ना, हम्बल रिक्वेस्ट. ओके, चलो. सो v इज इक्वल्स टू आई आर. ओके, नाउ फ्रॉम फ्रॉम इक्वेशन सेकंड में हमारे पास क्या था? वर्क इज इक्वल्स टू वी आई टी. यस, नाउ पुट दिस. ठीक है, पुट this in equation second. So from equation second we got this. Now so W is equals to what? I R I T. So it becomes I square R T. Yes,
Yes, sir.
just see it everyone. अभी मैं शॉर्ट में फिर से दिखा दूंगा, इतना मत दिमाग लगाओ. जस्ट यू नीड टू रिमेंबर द फॉर्मुलाज एंड हाउ वी गॉट टू नो दिस. ठीक है, देयर इज नथिंग टू लर्न इन दिस, ओनली द थिंग इज विच यू आर रिक्वायरिंग इट द प्रीवियस फॉर्मुला विच इज नीड टू बी लर्न. ओके, गॉट इट एवरीवन?
Yes, sir.
Yes, sir.
So another formula which we can get from this only, as we know V is equals to IR. So I can be written as V upon R. Yes or no? So from equation third we have what? W equals to I
W equal to
RT. So V W equals to, instead of I we can write, so it becomes V square RT. So this will be cancel out. So W equals to V square RT. Got it?
yes, sir.
So these work and current terminologies one options we will have sometimes when it going to ask in the paper numericals. ठीक है? So this is what? Now this is the work done, na? This is the work done, and capacity to do work is the energy. Yes or no? So
Yes, sir.
so just a second. Now, so the electrical energy supplied by the source will be W equals to V square T by R or I square RT or VQ. Okay, got it?
Yes,
Any of the
sir.
formula you can use. Even one more is left, है ना? One more is left. Let me write the whole. Just a second. See, so what we have studied for the work as a electrical energy work, W is equals to, that is VQ, which is also equals to VIT, which is also equals to I square RT, which is also equals to V square R upon T into T. Yes or no?
Yes, sir.
So this is the formula which you can remember as a part of energy supplied by the source. Now SI unit of energy is, so who gave it? James Prescott
Hmm.
joules. So SI unit of energy is,
Joules.
now tell me who didn't got it till here. Any of the thing. Jaldi se. Ashrita, Nipun,
Got it, sir.
Nipun,
Got it.
got it?
Got it.
हाँ चलो आगे आ जाते हैं. Now work is being done. Now electrical power. Now we have, that is energy we have done. Okay, that's the energy. Now electrical power. So power has been denoted by P. Yes or no? Yes.
Yes, sir.
Now in the previous chapter, what is the formula for power? Wait. Nipun, what is the formula of power? जल्दी स्पीड में आता है तो बताओ, नहीं आता है बताओ, नहीं आता है स्पीड में.
So
निपुण,
power.
हाँ आता है तो बताओ, नहीं आता है तो जस्ट टेल मी, डोंट नो.
So formulas are not so sure, sir.
नॉट श्योर, ठीक है भाई.
Sir,
ऐसा,
W by T, right?
हाँ W by T, ठीक है. हाँ, वर्क डन अपॉन टाइम इज द पावर. यस, पावर इज इक्वल्स टू वर्क डन upon time. Nippon, do remember and learn this, okay? Now work done upon
Yes.
time. Yes, so that is P is equals to W upon T. And right now we find out that W is equals to what? VIT.
Yes,
Yes
sir.
or no? W equals to VIT. If we put in this, so we will get the power formula as power equals to VIT upon T. So it becomes power equals to VI. This is the
Yes, sir.
important formula. Okay, that's power is equals to voltage into current. Clear?
Yes, sir. Yes.
Everyone, is it clear?
Yes, sir.
Now again we will play with these variables. Okay, so now we know from Ohm's law V equals to IR. So one we will get V equals to IR and another one can be written as I equals to V by R. Okay, when we just put the values individually for both of them, so we'll get again the two formulas we'll get, and that is P is equals to VI की जगह when we write VI की जगह we write V equals to IR. So it will be P equals to IRI, that is P equals to I square R. Got it everyone?
Yes, sir.
Okay, now another one which we can have it. So when I equals to V by R, then P equals to VI. So instead of V it will be VI R. So P equals to V square by R. Clear?
Yes, sir.
Okay, so now we got the three formulas for power. What are these formulas? Just see. These formulas are P equals to VI, P equals to I square R, P equals to what? P equals to V square by
V squared by R.
R. So these are the three formulas for the power. Okay, got it everyone?
Yes, sir.
So I can just write in the form of energy one part, that is work only. P equals to W upon T VI I square R and V square by R. Everyone got it?
Yes, sir.
Yes, sir.
Now, when we talking about the electrical power, so electric power, or we can say electrical power, है ना? Let's take the electrical power. Okay. Now this electrical power is having the some SI unit also must be there.
Yes,
Yes
sir.
or no?
Yes, sir.
So electrical power SI unit will be
What?
yes, watt, and that is W. But when this power needs to be in the energy consumption, then it is taken as kilowatt. Taken as kilowatt. Okay. It is taken at kilowatt.
Kilowatt.
Clear? So power can also be written as kilowatt. But for when? When?
Du- During energy consumption.
Commercially. Okay, electric that energy consumption, or we can talk about commercially. Okay, and on domestic purposes. Okay. So when you are taking it, commercial unit. Just remember, commercial unit, domestic unit, या फिर एनर्जी कंजम्पशन की when we are talking about the energy consumption, या फिर हम practical energy की बात करेंगे, then we will take in the kilowatt. Okay, so
Yes, sir.
so 1 kilowatt is equal to 1000 watt. Got it?
Yes, sir.
Everyone,
Yes, sir. Yes, sir.
है ना? Yes. Everyone clear?
Yes, sir.
Yes, sir.
So 1 kilowatt is equals to 1000 watt. So if we talk about the 1 watt, like see in the power already is there, so power is equals to VI. So P is equals to voltage is in volts only, current is in ampere. Okay, so that will be volts ampere. Yes or no?
Yes, sir.
So volts ampere can also be written as joule second inverse. See, either you write volts ampere or you write joule second inverse. So this all are equals to the watt, because it's been given by James Watt, that's why. So power is in watt W. Now we need to define the 1 watt. We need to define the 1 watt, like we have done for the 1 volts 1 ampere, na? Yes or no?
Yes, sir.
Na? Then similarly we have to define for the 1 watt. So it is electric power consumed when a current of 1 ampere flows through a circuit having potential difference of 1 volt. Yes or no? See, so P is equals to VI, na? So when 1 ampere current here and 1 volt potential difference is been there, then power is called to be 1 watt. Power is called to be 1 watt. Clear everyone?
Yes, sir.
Now we have the
Yes.
bigger units of power also. So power unit is watt, and 1 kilowatt is equals to 1000 watt. Okay, then 1 megawatt is equals to 10 to the power 6 watt. This is 10 to the power 3 watt. Okay, and then 1 gigawatt will be 10 to the power 9 watts. Okay,
So can you do the previous slide?
huh.
Done, sir. Thank you.
So now let's talk about the commercial unit. Commercial unit of electrical energy or energy consumption. Energy, we can say commercial unit of electrical energy, है ना? ठीक है. So basically we are talking about the energy consumption. Energy consumption. Energy consumption means how much energy is being utilized by a particular device. How much energy is being utilized by a particular device is called what? Energy consumption. Okay, so now, so let's consider what if suppose if an electrical appliance, okay, if an electrical appliance of power P watt is used for T second. So this is the only the formula for power, na? See, P equals to, है ना? What is the
Yes,
formula for
sir.
power?
Work by time.
Wait, एक second. What it's saying, see, if an electrical appliance of power P watt is used for T seconds, okay, for T seconds,
3 seconds.
then energy consumed will be, then energy consumed will be, so it is like work done, because energy consumed is the work done only. Just remember the things why I am writing this work done and energy and everything, because in the formula sometimes it's gonna ask you. Okay, ठीक है. So
Yes,
that
sir.
will be power into time, power into time, and the unit becomes watt second. The unit become watt second. Clear?
Yes, sir.
So this unit used as unit of electrical energy. Electrical energy. Everyone, is it clear or not?
Clear, sir.
Yes, sir.
Yes, sir.
हाँ हाँ, ठीक है. So it becomes electrical energy. ठीक है. Now in practical life, okay, in practical, what we see, in practical, or we can say in a daily way, daily uses and practice also, what electrical energy is measured in bigger units, that is watt hour. Okay, Before it was watt second, now it is watt hour. Okay, or we can
Yes, sir.
say, or it can be in kilowatt hour. ठीक है?
Yes, sir.
So now we have to define 1 watt hour. 1 watt hour. Clear? So what is 1 watt hour? It is the electrical energy. It is the electrical energy. One more part will be there, है ना? One more lecture will be there on this. Then because numericals are left ना, that's why. ठीक है? हाँ, it
Okay,
is
sir.
the electrical energy consumed by an electrical appliance of power 1 watt when it is used for 1 hour. When it is used for 1 hour. Okay? Getting it?
Yes, sir.
Everyone?
Yes.
Sir.
है ना? So 1 watt hour will be equals to, see, we can define 1 watt equals to 1 hour only, है ना? Now
Yes.
1 watt, now in the hour, if you are going to convert in the energy form, like you are converting in the joules, watt hour you are converting into joules, so it will be 1 watt only, and 1 hour will be converted into 3600 seconds. Yes or no?
Yes, sir. Yes,
And
sir.
watt, yeah, and watt second is 1 joules. So 1 watt second is equals to 1 joules. So now this 1 watt hour is equals to 3600 joules. Clear?
Yes, sir.
Yes, sir.
Everyone clear?
Yes, sir.
Yes, sir.
Now last part for today, okay? And that is 1 kilowatt hour. See, in this, these conversion is important, not the theory which I am writing, but I am writing it so that you don't have to just confuse with this part. So you can just read when you are doing the revision and something. Okay. So now what is 1 kilowatt hour? Okay. It is the electrical energy consumed by an electrical appliance. Same thing, same electrical appliance. Now instead of power 1 watt, we will write of power 1 kilowatt when it is used for 1 hour. Used for 1 hour. Okay. So now what we will do? 1 kilowatt hour. So 1 kilowatt into hour. So 1 kilowatt is been written as 1000 watt. Yes or no? Because we need to convert it into
Yes,
joules,
sir.
na?
Yes,
It's the
sir.
energy we need to convert into joules. And 1 hour will be equals to 3600 seconds. So it
Yes,
will
sir.
become how much? It will become 3, 6,
36.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5 joules. Okay. Now we need to write in a short form also. So in a short
36
form,
into 10 to the power 5.
yes, what happened?
36 into 10 to the power 5, no?
Hmm. एक second. It just got hang. See, I'm writing it here only, okay, because just getting hang, that's why. So now, how many zeros are there here? See, so when you shift 1, 2, 3, 4, 5, so 5 zeros are there. And in the scientific notations we have studied, and we know that we should take the variables in the till the 1 digits only, okay. So we need to consider the 6 also. So it becomes 3.6. Let me write this. 3.6. How many zeros we have shifted this side towards the left? 6. So 10 to the power 6 joules is the what? is the electrical energy consumption. Got it, everyone?
Yes, sir.
Okay, now after this we will find out the cost of it. How do we can find out the cost of the particular appliance? Okay, so this one more part will be there. Okay, and this we will find out how to find that cost of it. Then heat, about the heat, that is H equals to I square RT. Already we have written with W equals to I square RT, but in the next session we will do this. Okay,
ठीक है.
clear? चलो.
Yes, sir.